So hey nerds, this is Suman and in this video we're going to discuss about some calculus problems. So now up to some let us say how many up to 100. So let us go and do the 100 integrals. So it might be better to be good at calculus, right? So from now I'm going to post the videos about calculus that I am doing the calculus, or you can actually learn from other creators also. I don't like you have to watch my video. It doesn't make any sense. So we would be starting from the best of best. That means the usual formula that we had memorized in our class 11th and 12th. So we will be doing that in that identity relation, that how this identity came actually out uh, as a formula of some integrals. So we will be doing that, and let's go dive into the blackboard. So nerds, let's go and do some integrals, right? So I'm starting from the basic one, that is integral. Let's say we have this respect to with x, and that is x square plus a square. So you might all have heard about this integral and you might have memorized its formula, that is 1 over a tan inverse x by a with some constant c. So how we are going to tackle this out? So it would be very beautiful to substitute it with some another functions. Let's assume, so I'm just putting x is a tan of theta. So what would I get here? I get, if I differentiate both sides, I will end up getting dx over d theta, that is a sec square theta. So dx is going to be a sec square theta, and if I take this d theta over there, this will be dx is a sec theta d theta. So this is the relation that we have substituted x in terms of some arbitrary function theta and dx with some arbitrary with the respect of d theta. So now we can substitute our relation here, and we will notice something very much beautiful thing, that the dx is nothing but our a secant square theta d theta divided by, we have x is a tan theta, and if we square it, we will get a square tan square theta plus a square. So we will end up getting a sec square theta d theta over, if I take a square is common, and I get 1 plus tan square theta. So the a will cancel out, and the one remaining a came out from integration because it is a constant, and we will end up getting sec square theta d theta over the 1 plus tan square theta is nothing but our integral, that is sorry, not the integral, that is secant square theta. This is from the identity, that is secant square theta minus tan square theta is 1. So if you take tan over there, you will end up getting what? Secant square theta. So this secant square will cancel out this secant square, and you will notice that we only left off with the interesting term, that is integration with this respect to theta, right? So we all knew about this term out integrate. If you have dx, you will end up getting x plus c. X plus c. So in terms of x dx, we have d theta, and in terms of x, we will end up getting theta plus some constant c. So this would be 1 over a theta plus c. Okay, but I had wrote my formula in terms of tan. So what am I going to do now? So you can see from here, from this relation, I have x is a tan theta, right? A tan theta. So I can write x over a is my tan theta. This makes sense. And if I take inverse of tan inverse x by a, and I will end up getting tan inverse tan theta, and this is an identity that you will get theta. So in terms of theta, you can replace by this term, and you will end up getting 1 over a tan inverse x by a plus with some constant c. And if there is some limit within a of theta from a to b, you will not get this constant term because then it will be a definite integral, right? So this is the first integral. So this would be our first integration video, and this would be our first integral. So we have derived how this formula came out, that is integration with this respect to x, that is x square plus a square. We get 1 over a tan inverse x over a plus with some constant c. So this is how the relation or the identity that is obtained, that we have, that I had also memorized in my earlier classes, that is in my class 11. So this would be my first integral part, and you can actually share your own problems, integral problems, with me in the community tab. Yes, I had make it open for everyone, that where we can get more knowledge and more things to be done there. So you can actually send me some other integrals there. Up to there, bye bye.